I think we can get started. So let me share the agenda. First of all, welcome everybody to the review meeting for the 1.125 release. We have the following 5 topics for today. I will start with a short update about the GEP28, the autonomous shoot clusters, and the next increment we reached there with the etcd management via etcd-druid. Then we have Mark taking over for Tim with a topic from the recent hackathon in Sofia, no more RBAC collisions in Kubeconfigs. Ismail will talk about the global max allowed values for VPA. Then we have Alexander for more robust config handling and Gardener Node Agent. And finally, Toby will present us a short demo for the new cluster API provider for Gardener. All right, then let's dive into the topics. I said I will start with an update for GEP28. So this is about this pull request here. And yeah, as the title already explains, the gist of it is that etcd-druid is now taking over the management for the etcd pods in the autonomous cluster. So previously, we just had a so-called bootstrap etcd that we set up with minimal configuration that can just start up basically, but doesn't have any more sophisticated functionality that we are usually used to, like backup restore or compaction or whatnot. And yeah, with this change, we now want to bring etcd-druid in charge because it has all the capabilities and functionality for the production grade management of etcd basically. So simply what we also do for shoot clusters. I will directly jump into the demo because it may take some time until it is ready. So I have prepared the setup already a little bit. I am on the control plane machine, but the more important pane is the lower one. Let me know if the size is not big enough. So we are watching here the pods, and then we also watch the backup bucket, backup entry resources. Currently, they don't exist yet. We watch etcd resources and stateful sets. So let me start the flow. I think it will take a while. I will explain a bit what will happen. So what we are currently seeing is that Gardener Resource Manager is restarted because it has to run in the host network and the pod network now. Now also the extensions are restarted. And once this is done, we will just deploy a backup bucket and backup entry resource, like for regular shoots. Those are then later used by the backup restore sidecar. And the local setup is just a folder on the host machine that is basically mapped into the kind container and then later into the etcd pods. And there the backups are then stored. Yeah, so this is happening right now. Backup bucket is already reconciled. Backup entry is reconciled. And now etcd resources got also created. And now the cluster is down, which is expected. So what is basically happening is that etcd-druid has reconciled the etcd resources. And we are now replacing the bootstrap etcd with these etcd resources that have been created by Druid. And this, of course, involves a downtime. Etcd cannot be simply replaced one by one without having a cluster or something without a downtime. So we are just exchanging them. The trick here is that we are reusing the data directory of the bootstrap etcd. So all the data that we have put in there before is also available later. And yeah, as you can see in the log, it is now waiting for all the static pods to come up and have the desired state. This usually takes, I don't know, depends. Sometimes it takes a couple of minutes because first of all, the etcd pods have to be up. Then Kube API server has to be ready again, and the kubelet does not restart these static pods too often. So if they fail, let's say Kube API server fails because it cannot talk to etcd yet, and it might take a while until it restarts them again. But we can also use the opportunity to look a bit into the system. So and check how we can find out what's going on. So there's this var log pods folder on the machine. And we see the logs here for all the pods that we have. And here in this section, we have the etcd pods. So we could, for example, check the logs for etcd events. There are two containers, backup restore and etcd. And we see here that the initialization is still in progress. Here are the logs for backup restore. And similarly, for the etcd main, these two pods. Here are the logs for the etcd container and for the backup container. They are here. Yeah. So here we could check if something is not working as expected, what the pods are saying, why the flow doesn't progress and why we don't have connection via kubectl anymore. Yeah, but meanwhile, you can see it has continued. So if we start our watch again, we should see our cluster. And yeah, there's currently a bit of restarts involved because the Kube API server was down. The controllers need to reconnect and so on. So this is normal. What I would like you to pay attention to is the stateful set here. So just like we translate the regular Kubernetes control plane components with deployments, so Kube API server and so on. I think we showed in one of the last review meetings that we create deployments with replica 0 and then translate them into static pods. The same approach is followed for the stateful sets of the etcd. So if we check this, then we see the stateful sets with replica 0 and for the Kube API server and so on. The others, we also have this. And with this, we can just reuse the logic that we are used to for c-shoot setup, where we might have extensions that want to register webhooks in order to manipulate anything in the configuration for these components. They can still do that. It will be part of these stateful set or deployments here, and then Garden ADM can translate the pod templates back into a static pod manifest. Okay, so if we again look at the pods, now we see there's etcd-druid, of course, and we no longer see, especially these bootstrap etcds, but just regular etcds with also two containers here. So now we can check on the host machine. In the dev folder, there's this local backup buckets, and then there should be a folder for the backup bucket. So this 9D7 should correspond to the name of the backup bucket that is here. This one. And then we have, as usual, a folder for the cluster. And yeah, then we have our backup files here. So the backup restore sidecar of the main container has already created a full snapshot some couple of minutes ago. All right. So then let's get back. This is basically it for the PR. If we take a look at the issue, here we are in the Garden ADM init issue list. And you can see that we basically finished all the items for now that we would like to finish for init. So this was actually the PR, the last one. And now we are focusing a bit more on the join command because we want to now support also joining additional control plane nodes in order to have HA, also etcd clusters and so on. But yeah, for this, we probably need to enhance the Druid a bit more to understand this scenario a bit better in order to properly instrument this whole member joining process that is currently somewhat aligned with a c-shoot setup, which doesn't quite fit anymore in this scenario. So we expect that for HA, it won't be that easy that we like for single node that we just have implemented. But yeah, we will get there. So this is the next step, supporting joining additional control plane nodes, then also making the etcd HA. And otherwise, we are looking into the Garden ADM Connect scenario. Now that we basically have created a cluster, which is kind of ready to be used, more or less, our goal is to connect this cluster to Gardener and then deploy something like a Gardenlet into it that can keep the cluster up to date and perform all the lifecycle and day 2 operations. All right, I guess that should be it for this topic. Are there any questions? Okay, apparently not. And thanks for listening. And let's continue with the second topic for today, presented by Mark about the RBAC collisions in Kubeconfigs.
Hello, everybody. As Raphael said earlier, I'll be filling in for presenting a change that Tim Osner did. Before I get to the change, I will show you the problem first in a little demo. I have a local Gardener running using the local setup. As you can maybe tell here, I'm a few commits behind, specifically exactly behind the change that Tim did. I currently have a local shoot running, a workerless shoot actually, that's up and healthy. And imagine now in this tab, I'm basically taking the role of a cluster admin or whatever. So what I can do is I can create a temporary kubeconfig for the shoot cluster. I will be using the viewer kubeconfig. So anybody using this should only have read permissions inside the cluster. And I will then be handing that over to the other role that I'm now taking, jumping over to the other tab here. I got this viewer kubeconfig now for the cluster. So what I can do is I can read the contents of this kubeconfig file, and I will decode the certificate data inside to take a look at what username is in there and what organization I'm assigned to. What you can see is if I jump back up to the subject, I'm part of the Gardener Cloud system viewers, and my username is Kubernetes admin. So that's the username that requested this kubeconfig against the Garden. What I can do then, of course, is I can assign this as my local kubeconfig file, and I can start looking into the shoot cluster. So let's start by reading namespaces. Since we have a viewer kubeconfig, I would expect that if I try to create a namespace, my shiny new namespace, that should not work. I only have read permissions. But as you can see, that's a little bit surprising. The namespace got created. And yes, it's actually there. So that's a bit confusing. Let's check what if I read my permissions. We do see that there's a whole bunch of read permissions here, but also basically I'm allowed to do anything on everything, even though I'm using a viewer kubeconfig. We can then check maybe the cluster role bindings to find out what's going on. Of course, I did a little bit of digging already, and if you remember the username that we saw from the certificate data, there seems to be a cluster role binding called Kubernetes admin. If we read this one, output it, we can see that coincidentally, this cluster role binding assigns the cluster admin role, which gives you permissions to do everything, to the user named Kubernetes admin. And that explains why now we're basically, even with the viewer kubeconfig, able to do everything inside the cluster. Now, the change that Tim worked on was part of the recent hackathon that took place in Sofia. Here you can see Tim. He doesn't look like me, so that's somebody else. And this was part of this topic of preventing the viewer kubeconfigs exposing the requester's identity, plus this potential privilege leak that you've just seen, that I could do more with the viewer config than I should have. The pull request was this one. Basically, the fix is to add a randomized prefix to the username in this generated kubeconfig to avoid these name clashes. And the change itself is rather simple. As you can see here, it's just a 10-character random string, which is then prefixed, separated by a colon inside the common name of this certificate. And if you then are using a newer version of Gardener and you would create now a new kubeconfig with a new version, the output would look something like this. So I already got a new kubeconfig using the new Gardener version with this change. And as you can see, if we take a look at the subject again, this is still the viewer role, but the username has the random prefix still requested by the Kubernetes admin. That's already it. Are there any questions? If not, then back to you, Raphael, for the next topic.
Yeah, thanks, Mark. No question. Then we can directly continue with the next topic presented by Ismail, global max allowed values for the VPA.
Hi, folks. I hope you can see my screen. I will present this PR, as Raphael said, global max allowed for VPA. In short, the VPA or the VPA recommender in particular had previously the following known limitation. The limitation was that the recommendations that the VPA recommender issues are not capped to the cluster size, or the VPA recommender is not aware of the cluster size, so it can recommend resources which are larger than the cluster can host, and this causes pods to go to pending state, which means disruption for the workload, and there is usually no auto recovery from this case. Last year in the Hack the Garden hackathon in December, with Toby and Max, we contributed the following PR to the upstream. It is about making possible VPA recommender to accept global max allowed resources. And with this, cluster operator can set or can instruct the VPA recommender to do not provide a resource recommendation higher than these values configured via these flags. Okay, and now with this PR, we finally adopt this feature on Gardener. Now seed, should seed and Gardener resources and the VPA specs in these resources accept max allowed fields. Okay, let's go to the demo. I prepared a local step with make kind up and make Gardener up. For the demo purposes, I will use the resource consumer. In short, the resource consumer is an upstream testing image from Kubernetes, where you can, via HTTP requests, instruct the resource consumer how much CPU or memory to use and for how long. So it's quite handy for testing VPA in local step and in end-to-end tests. Okay, here I have the deployment of the resource consumer. It's exposed also via service so that I can call it. I will create the resource consumer deployment first. I also have a VPA for that deployment. Note that the VPA does not specify any max allowed. I will also create the VPA itself. Okay, let me watch the resource usage of that pod. And let me also watch the VPA and the recommendation that VPA provides. For the purposes of the demo, I will request this pod to use 2 GB of memory. That's also, with this command, we basically run a pod, and this pod calls the resource consumer service and instructs instructs it to consume, in our case, 2 GB of memory for 5 minutes. Okay, it looks like the pod did its job. And we can see that, yeah, for a short time we saw that it was consuming 2 GB of memory. Okay, my pods, I think it was evicted by VPA. Okay, that's interesting. Okay, maybe I forgot to specify initial resource requests. Let me check one thing. Oh, yeah, okay. Yeah, I think that was my fault. I forgot to specify initial resource request, and that's why VPA evicted it to provide the minimum recommendations. So yeah, I have to issue the consume mem thingy once again for the purposes of my demo. Yeah, it takes a little bit time until the metric server sees the new resource usage, and the VPA also provides a better recommendation. Okay, now here we have memory usage of exactly almost 2 GB. The next step would be to wait here the VPA recommendation to be updated according to this memory usage. And after that, okay, here we see VPA recommended that amount of bytes. If we convert it to gigabytes, it would be something like 2.3 gigabytes. And now VPA, of course, will perform eviction in a while so that it can apply this recommendation. Yeah, I think it already evicted. What I want actually here to demo with regards to the global max out is that now I can edit the seed spec, for example. I can go to the vertical pod out scalar field, and I can specify max out the new fields. Here I can also specify CPU. I can specify CPU and memory. For the purposes of the demo, I use only memory. And let's limit this for the purposes of the demo, the global max out memory to 1 GB. Let's save this. And let's wait until the seed is successfully reconciled and our VPA recommender is updated. Okay, that was fast. If I inspect the VPA recommender deployment now and grep for about, yeah, here that should be the flag that got now set after we updated the seed spec. Okay, and the next thing would be the VPA recommender now should, let me again curl the resource consumer pod to use 2 GB of memory, and the VPA recommender's recommendation should be now capped to 1 GB. Okay, it's okay, it's still preserved. Okay, now the pod again is consuming 2 GB of memory. Okay, here we see that the memory recommendation was capped to 1 GB. Okay, this is the demo that I wanted to show. Yeah, for the purposes of the demo, I used actually values which are maybe not really interesting in real world use case. In real world use case, the recommendation for this global max out to prevent pods from being pending is to set this global maxwell to the largest nodes allocatable minus the resource request of the daemon set pods and minus a safety margin. So if you run, for example, a shoot or a seed cluster with 8 gigabytes of memory with machine type that comes with 8 gigabytes of memory, you usually have 1 gigabyte for the cube reserved system or system reserved. And if we say that your nodes allocatable with 7 gigabytes, then you have to also subtract the resource request of the daemon sets and put a safety margin, and then you can configure your global max out. And in that way, you can prevent pods from being pending due to too much recommendations from VPA recommender. And one final thing that I want to add is that if VPA if the VPA resource specifies a max out, you know that you can specify in the VPA resource itself inside the max out field. The VPA max out takes precedence over the global max out. Okay, that was all that I wanted to show. In case you have questions, I'm here.
Great. Thanks, Ismail. Is there any feedback, any questions?
Also, thanks to Toby and Max, we invested a lot in this topic in last year in the hackathon. So it's also their contribution here in this work.
Yeah, thanks for mentioning it. Okay, it seems there is no further feedback. Then let's hand over to Alexander for the more robust config handling in Gardener Node Agent.
Hello, so I'm going to present you the form PR, which was created during the Sofia hackathon together with Rada and Oliver. This PR was a response to an issue recorded by Oliver, where the Gardener Node agent, when there were breaking changes to its config in a new Gardener release, there were cases where the new Gardener node agent would not reach the nodes, and the old one would use the new configuration, which had breaking changes, and it would fail when Koa should back off. So for the fix, we simply changed a bit the Gardener node agent to now take config dir as the path to its config and not the config path itself. And in this config dir, it searches for a file that has as suffix the version of the Gardener that is in use, and we can see this change in local setup. Here I have created a local shoot, and now I'll execute into the node of the shoot, and there we can check the Gardener node agent. Let me just type it. And here we see its flag config dir, and if we check this dir, let me go there. Here we have the config itself, and as you see, there's the version, and during an update, the new config will be created as well with the new version, for example, 1.127. They will live together for a short while, and after that, the old config will be garbage collected. This was the change. Thank you.
All right. Thanks, Alexander. Then over to Toby for the last topic for today, the cluster API provider for Gardener.
Yeah, hi everybody. So let me at first share my screen. So yeah, today I want to present the cluster API provider Gardener. So basically, maybe some of you did not hear yet, but we've basically published a way for people to use Gardener through cluster API means. So what this basically means is that, just like any other provider for Google or AWS or whatever, Gardener can also be used to provision clusters through cluster API. And this basically works by us implementing every interface or almost every interface of what cluster API provides. So this means that we basically split up the shoot resource into different resources that basically lives in this kind of cluster API world. And what we then can do is install a provider in this cluster API management clusters. So for example, somebody could also already use cluster API to provision clusters through AWS, etc. And now they can install the Gardener provider, target a Gardener cluster, and start creating clusters. And without much talking, I want to actually show you a local demo. So in our local demo, we have everything packed into one single cluster. So we have our garden or virtual garden or runtime cluster and our cluster API management cluster all in one box, so to say. So we can see that we currently have no shoots and we also have no clusters. And if we want to now create shoot clusters, I can show you, for example, an example of a workerful shoot cluster. So we have our cluster API but cluster API objects that then reference basically our CRDs. And what that basically means is that we can specify in these CRDs, for example, in the Gardener shoot control plane, a shoot spec, just like we expect, but it's not the whole shoot spec. It's basically split up also into Gardener shoot cluster, what basically happens on the more seed side, for example, the region, etc. And also we have the worker pools, which are now referenced by the machine pools to the machine pool API. But without much talking, what we can now do is we can apply this. And if we now look if there's a shoot, we see, there's a shoot that it's now being created. And if we, for example, look at the cluster now, it's called Hello Gardener and it's provisioning. And the good thing is that, for example, if we look in the Gardener shoot control plane, we see also the status of the shoot being synced to a field called shoot status so that you can also see all of the stuff there. But that should not end there. So we also want to do some kind of operations, not only from one side, but also from both sides. So if we, for example, edit this Gardener shoot control plane and say, okay, we want to increase the logging verbosity of the Kube API server, we can now look at the shoot on the other side, so to say, and see, where is it? There. We see that the logging verbosity was increased, so synced, so to say. Now we can also, for example, if there's some, we still don't want to lose the ability to do our cluster management from Gardener side, so to say, also defaulting takes place, etc. We can also edit this shoot and say, okay, no, from the Gardener side, I want to turn that back for whatever reason. And if we look at the cluster API side again, we can see that it got also synced back again. So we have this bidirectional sync, so to say. Of course, if we look now, it's still provisioning. And this takes it some time. Let's say I don't want this anymore. we can also delete this, and this basically trickles down through everything and instructs Gardener to also delete the shoot. So let's see. I can also just get the metadata. So I think that's enough. And we see that it also got confirmed the deletion, and the deletion timestamp was set. And once everything got healthy once, then it will be deleted, which will take some time, and I don't think we need to really wait for that. In addition to that, what is a bit hard, would take too long to demo, I think, is not only we can use this as a standalone cluster API provider, but what's also possible is that you can use this against KCP. So there you don't need this this cluster API management cluster, but you run the provider against a KCP server. So basically all of the CRDs live in there, but the provider still then takes care of everything, and it basically just works plug and play in that matter. And yes, that's about it. If you have any questions or would like other features or whatever, feel free to create an issue or reach out to us. And also, in this case, special thanks to Luca, who together with me, we worked on that, and to everyone also who provided feedback and contributed to this. Thank you very much.
Good. Thanks, Toby, for the demo. Is there any feedback to the cluster API provider? Or any questions? Nope. All right. Then that was the last topic for today. Means we can close the call. Thanks, everybody, for joining. Thanks to all presenters, and see you again in 2 weeks for the next occurrence. Have a nice time. Bye-bye.
See you. Bye-bye.
Thank you. Bye-bye.
Bye bye.
Thank you. Bye.